What's up, everyone? This is LeetCode 75, sort colors. So we're given an input array nums with a bunch of integers that are supposed to represent colors. There's three colors, red, white, and blue. And we have to sort the colors so that they're adjacent to each other. Honestly, don't pay attention to the colors part. I think it's kind of confusing. Just think of it like this, right? We're given an input with integers 0, 1, and 2, and we have to sort them in ascending order. So the ones should come first, then the zeros should come first, then the ones should come, and then the twos should come last, right? So that they're sorted. Now our input's not sorted, right? That's what our output has to be. Our output has to be sorted. So we're basically just given three numbers, zeros, ones, and twos, and we have to sort them. But of course, we can't use a sorting function, right? So that makes the problem kind of tricky. You might be tempted to use like a two-pointer approach or something, but you'll find out that's not that efficient, right? Because we have to, well, first of all, we have to use constant extra space, right? And we have to do it in one pass. So there's certain constraints put on us because they want us to kind of nudge us towards a specific algorithm that you can actually use to solve this. It's kind of hard to come up with on your own, but we're going to learn it. So there's actually two approaches that I know of how to solve this problem. We'll go through the less efficient one first, and then the more efficient solution last. So we'll go through the first solution, which is a little less efficient, but the gist of it is really that you're going to do two passes instead of one, right? So we're going to go through this input array, and we're going to count how many zeros we have, how many ones we have, and how many twos we have. Then we're going to go through it again, and if we have two zeros that we counted, the first two numbers should be 0, right? So this 2 has to get replaced, right? That's kind of the idea. Is you're going to count the frequency of zeros, ones, and twos. Then you're going to do a pass again, and you're going to basically modify the array to so that it's sorted, right? So we're going to do that. It's really not too complicated, this inefficient solution. It's just not optimal, right? But it's still worth knowing because it is an interesting approach. It still works. So we're going to say for I in range, length of nums, right? If nums of I is 0, then 0 gets incremented. Else if nums of I is 1, then 1 gets incremented. Otherwise, the 2 gets incremented, right? So we're counting up the frequencies, really. That's all we're doing. You can use a hash map. I'm just doing it with the variables. It's up to you, really. So we're going to say for I in range, length of nums, right? This is our second pass, right? If we have zeros left over, let's just replace whatever we're on, right? We're going to say nums of I is 0 and decrement the variable, right? Else if 1 has leftovers, then let's replace whatever index we're on with a 1, and we're going to say 1 minus 1. Else we can just replace it with a 2. Okay? I think it's kind of a simple approach, but it's not too hard to understand, I don't think. It's just not that efficient. That's kind of the issue, because you're doing two passes, right? But anyways, I made that quick because I want to show you the efficient solution, which is kind of the problem. Which is kind of the point of this problem, because it's a very specific algorithm to this case. And if you're given this problem in an interview, I think they're going to expect you to use the optimal solution, the optimal approach, because like I said, it's very relevant to this problem specifically, and it's kind of an obscure algorithm if you've never heard of it, but it's called the Dutch national flag algorithm, right? And kind of the gist of it is that the Dutch national flag has 3 colors, right? So you can see how it ties into this problem, where we are also given 3 colors, red, white, and blue, right? Just like the Dutch national flag. And we basically have to sort the colors, right? I mean, it's basically it basically is the Dutch national flag problem. It's just kind of worded differently, at least the title, right? But there's an actual algorithm we can use to solve this problem, right? And this is what the algorithm is called, right? And the gist of the algorithm really is that, well, like I said, if you use a 2-pointer approach, you're going to run into issues because there's 3 colors, right? Not 2. And the algorithm, basically, we're going to use 3 colors, or not 3 colors, 3 pointers, right? A left pointer, a right pointer, and a middle pointer. We'll call the middle pointer just I. And the idea is the left pointer is supposed to put all the zeros to the left side. The right pointer is supposed to keep track and put all the twos to the right side, and the I is supposed to keep all the ones in the middle. And the I is also helpful for the swapping whenever we encounter something that should be on the left side or the right side, right? Because again, our input array is unsorted, right? So we're going to start off by setting our pointers, okay? So the left pointer at the start, the right pointer at the end. And the I is going to start at start as well, right? And we're going to say while I is less than equal to R, we have stuff to do, right? Because once I passes R, we know that we already did all the possible sorting that we could. Okay? So we're going to say if nums of I, remember I is supposed to basically keep track of the ones, but it's going to move forward. It's going to move forward. Like the left pointer is here, right? The right pointer is here, and the I is here, but the I is going to move forward whenever we can. Right? So if nums of I is 0, we're going to say we can swap. So if nums of I is 0, we're going to swap with the left pointer. Because again, we want the zeros all the way on the left. And when we do that, we can move the left pointer forward. And then down here, by the way, outside of the if statement, we're going to move the I pointer forward. And I'll explain that in a bit. Now we could also have another case where nums of I is 2. And again, what did I say? The right pointer is supposed to keep stuff on the right side, right? So we're going to say nums of R, nums of I, and do the swapping. And again, this is Pythonic, right? But you can kind of do the swapping on one line. You don't have to use a temp variable, but if you're using another language, you might have to use a temp variable. Okay, so in this case, we're going to move the right pointer backwards, right? Because we did the swapping. However, in here, we want to move the I backwards. And the reason we have to do this is because, well, technically, this I here is supposed to move. The reason we move the I is because this is basically cases where, well, if we move the left pointer forward, we want to move the I forward. However, there's also another case. What if nums of I is equal to 1? In that case, we want to move that forward as well because we don't want to do anything, right? Because again, the I is supposed to keep the ones in the middle, basically. And so that's why the I plus 1 is outside the if and the else statement. However, if we have this, right, this nums of I is equal to 2, and we do a swapping, we don't want to move I forward. We want to actually move it backwards so we kind of keep it in place, right? You can see how basically we move I backwards, but then down here it gets moved forward. So it's technically in the same spot. The reason we want to do that is because if we move like a 0 from the right side to the middle, we don't want to move the I forward. The reason is if we move a 0 from the right side to the middle, we don't want to move the I forward because we want that 0 to be on the left side. So we have to swap it to the left side in the next step, right? So that's why we don't want to move I forward, right? I'm going to give you an example so this will actually make a ton of sense, right? Imagine you have something like this. We have 0, 1, 2, 0, right? And I'm going to set my pointers, right? So we're going to say L, R, I. Okay, let's run through this algorithm, right? So, nums of I is equal to 0. Sorry, I should say equals. That was my mistake. But right. So yeah, it is. Nums of I is equal to 0, or equals to 0, right? So we're gonna do the swapping, and we're gonna move this forward. Right, and again, it gets swapped with itself because the nums of I and nums of L are at the same spot, but that's fine. And then we exit the if statement, and down here, right, we move the I forward. Okay. Now nums of I is what? Well, it's not 0 and it's not 2, so we just move it forward, right? Okay. Now nums of I is 2. Okay. So now we want to swap these, right? So we're gonna have 2, 0. Now, imagine if we didn't have this I minus 1 here, what would happen is we would exit the else if, and we would do I plus 1. And now we have an issue, right? Because this 0 here has to get swapped with this 1. And that's why we have to have this here, is because we have certain edge cases we have to handle when we swap something from the right side to the middle, wherever I is, right? Because like in a case like this, right? Imagine we don't move I forward, right? Like if we have I minus 1, okay? We have I minus 1. We exit the else if, we do I plus 1. Oh, it's at the same spot. Nice. Now, when we go up here in the if statement, now we swap this the 0 with this 1. Or sorry, 0 with this 1, right? So you can understand, hopefully now, why this is super important. Is because there are edge cases when we swap from the right side to the middle. It's possible sometimes that we want to swap that middle element to the left side because it's 0 or something, right? And that's why we need this here, okay? So that's basically the gist of the algorithm. It's slightly complicated to come up with on your own because you do have to account for the edge cases. That's kind of the tricky part. But this should work. Yep. Anyways, I hope that helped. That's the Dutch national flag algorithm. I hope that helped. I know it's a little bit obscure, but honestly, I don't think it's that too difficult to remember. But definitely kind of a bit complicated to come up with on your own if you've never seen it. But I hope this helped, and I'll see you in the next one. Peace out.